Okay, so we're going to discuss missing data. Missing data is when a variable or item from a particular scale has no response from a particular case or participant. Missing data can occur in instances when participants do not respond to a question in a particular survey. When we have identified that we have missing data, we want to determine the type of the missing data itself, whether or not it's missing completely at random, in which there's no pattern in the missing data. If it's missing at random, in which there is a pattern to the missingness, but it's not associated with the dependent variable, or whether or not it is missing not at random, in which there's a pattern of missingness associated with the dependent variable, as in a particular group not responding to particular items. This is what we hope to not find within our data set. There is an SPSS test for missingness, which we will discuss now. So here I have the exercise on alertness data set, and as you can see, I've actually added an extra variable, fitness, to illustrate some further points that we'll discuss a bit later. First, what we want to do is determine the degree of missingness, basically, whether or not it's MCAR. So what we're going to do is go to Analyze, Missing Value Analysis, and we're going to place our two dependent variables into quantitative variables and also the grouping variable into the categorical variable. We then click on EM, which stands for expectation maximization, which is the most robust method here, and then we go OK. We'll determine on the chi-square distribution. And what we have here is a very high significance level. Now, our null hypothesis for the MCAR test is that data is missing completely at random. So if it was significant, so under 0.05, then we would presume, or we'll reject the null hypothesis and presume that it is not MCAR. So this is exactly what we're looking for here. Now that we have identified that we have MCAR data, so missing completely at random data, we have to determine what to do with this missing data. So we can essentially go listwise deletion, so deleting the case. The problem with that is that we are also deleting the information on the other variable. We can replace the missing data with the mean of the cases across that item, or we can also replace it with a common point. So if you have a 6-point Likert scale, you can replace it with the number 3. So we'll discuss how to do that. Now, if we want to replace with the mean or the common point, we can do that quite easily within this data set because it's quite small. However, if you have a much larger data set, you can go to transform, recode into the same variables, choose your dependent variable that you'd like to change, and here we have 2 missing data points on fitness and old and new variables, and just go to system or user missing, and value we'll choose 3 for common point, and just add. And now if we look at the data again, we can see that the missing data has been replaced with 3. Although there are pros to the mean or common point replacement, such as it's relatively easy and efficient, and it maintains the relative average of a data set, the cons in these situations actually far outweigh the pros, because a mean or common point is unlikely to reflect the true score of the participant. And with multiple missing data within your data set, you could be potentially committing a type 1 or type 2 error due to the significant reduction of standard error by centering everything within the common point or the mean. However, a more robust method than both mean and common point replacement is multiple imputation, in which you're using regression to predict scores of the individual based on their other responses to the other variables, as well as those of the group that the participant belongs to. We can go to Analyze, Multiple Imputation, Impute Missing Data Values. Now we can take all of the variables within the model. We want the independent variable as well because that's going to help us predict the actual scores. So we want to change this to 1 imputation. and it requires us to rename or to develop a new data set, so imputed data set. So impute. And it's important to actually go into constraints as well. Multiple imputation can actually impute scores beyond a possible range. So minimum we want 1 and then 6. Oh, it's wrong variable. So 1 and 6. And we want to change this to impute only, but we're using the others as predictors. So we can impute and use as predictor. Yeah. And now SPS has actually created a new data set. So what SPSS does is creates a new data set with the imputed data. It's also created a new variable, so imputation. So 0 represents the original data, and 1 down here represents the new imputed data. And as you can see, it's highlighted the replaced values. So we've replaced that one there. So as you can see, by replacing common point, which this would have been 3, this is actually 5 based on the scores of the other variable as well as the scores within the group. So it's a more accurate representation of this individual's true score. Just a couple of further points on multiple imputation, just for the sake of clarity here. It is best to just run one multiple imputation. Ultimately, with each imputation on the same data set that you run, you will get slightly different results for the missing data. And this is essentially because each imputation will use the same number of items to predict that missing data, but the items themselves will be just randomly chosen. So each time there's a randomly different assignment of those items to predict that missing data. There will be a difference in terms of your imputed data, but that difference will be so insignificant. It will be no more than 0.1 in comparison to the missing data obtained through other multiple imputations. So the multiple imputation, as we've discussed, will create a new data set for you. This new data set will include both the old, so impute 1 it's called, and the new data set, impute 2. So because it contains both data sets, so the old data set with the missing data and the new data set with the imputed data, you can just delete the first half of your data or the new data set, as this is repeated in the second half, but with the addition of the imputed data for the missing data. And all imputed data will be highlighted for you, so you can determine which ones have actually been changed as a function of multiple imputation.